Okay, let me demonstrate the concept of relative velocity is always perpendicular to the angular velocity and relative position vector. So we have point A and point B here, and we'll use this to represent our r vector. And this is r from A to B, means the position vector B relative to A. So this is our r b slash A, but it's a vector AB. So I use this little n here to represent this is where it's pointing. So our position vector, and our position vector can rotate either this way or this way. We'll demonstrate both. When our position vector rotates counterclockwise, our right-hand rule tells us it will create an angular velocity pointing up. So this is our angular velocity, and again, red means the direction is pointing up. Now, our relative velocity is given by the angular velocity cross product with the position vector. So we can use our right-hand rule, the angular velocity omega cross the position vector, like this. And my thumb gives me the velocity, b relative to a. So when it rotates with cross product, creates my velocity, b relative to a, which is perpendicular. It's perpendicular to the position vector. It's perpendicular to the angular velocity, okay, perpendicular to both. And then another way, if now I'm rotating clockwise, while I'm rotating clockwise from A to B, I'm creating a downward angular velocity. So now our angular velocity will going down. So we'll do the omega cross RBA as this. Okay, so omega to the r like this. And then my thumb will give me my new relative velocity pointing this way. Okay, from A to B while I'm rotating clockwise. The relative velocity is perpendicular to the position vector r, is perpendicular to the omega, the angular velocity. So both way. Either I'm going counterclockwise, my relative velocity will be like this, or I'm going clockwise, my relative velocity will be like this. So our relative velocity is always perpendicular to the omega, angular velocity, and the relative position vector, b with respect to a. It will be the same if we do b to a, or the relative velocity of a with respect to b. So when I'm rotating now counterclockwise, I'm creating a upward angular velocity. And then rotating this way, I'm using our right-hand rule here again. Omega cross r, I'm creating a velocity pointing this way. Hope this helps.